Hello friends, good morning. In today's lecture, I will explain classification of insulations, difference between dielectrics and insulations, and difference between bushings and insulators. So, I am going to explain all these three things through PowerPoint presentation. The first classification is according to the material. In this first category is gaseous insulation. This is used in transformers, circuit breakers and lines. In air-cooled transformers, the air is being used as cooling medium as well as insulation between winding and the body of the transformer. In air-cast circuit breaker and air circuit breakers, this air is acting as cooling medium, that is arc quenching medium, as well as when circuit breaker contacts are open, it is acting as insulation. In transmission lines, the insulation between the lines is air, so that is gaseous insulation. Second category is liquid insulations. It is used in transformers, circuit breakers, as well as in oil-filled cables. In oil-filled transformers, oil is acting as cooling medium as well as it is providing insulation between winding and the body of the transformer. In circuit breaker, oil is used as arc quenching medium as well as when circuit breaker contacts are open, it is acting as insulation between two contacts. Next is solid insulation. In all machines, the windings are used. Windings are having conductor and insulation is on that conductor. So solid insulation is used in all machines and lines. You have seen this type insulator, pin type insulator, string of insulator, strain of insulator. They are isolating the high voltage conductor from the tower that is grounded. Then there is vacuum. Vacuum is used as insulating medium in vacuum circuit breakers. The next category is composite insulation. Composite insulation is layers of different insulating materials. For example, in oil-filled transformer, on the winding, there is solid insulation. Then oil is acting as insulation between winding and the body of the transformer. So first layer is solid, second layer is oil. So this constitutes the composite insulation. The second classification is according to the usage and the location of the insulation. The first is external insulation. When the insulation is externally provided, it is called as external insulation. And when it is inside the equipment, it is called as internal insulation. So, if you are able to observe the insulation, then it is called as external insulation. If in the machine you are not able to observe the insulation, it is called as internal insulation. Example, in transformer, the winding insulation and the oil medium are inside the body. So they are internal insulations. Whereas the bushings outside on the top of the transformer are the external insulations. Similarly, in the transmission line towers, you can observe the insulators. So they are external insulators. Then third classification is according to the ability to recover back the insulating properties. In this, there are two categories. First is self-restoring insulation. These are the insulations which can recover back its insulating property after a disruptive discharge occurs. Example, breakdown in air or oil medium. When breakdown is in air, that I had explained you, that is called as flashover. When it is in the oil, it is called as spark over. Next is non-self-restoring insulation. That is the insulation which cannot recover back its insulating property after a disruptive discharge occurs and causes a permanent damage, that is breakdown through a solid dielectric. So if we are using solid dielectric and a puncture occurs, we cannot reuse that insulation. So So that is non-self-restoring insulation. Now here is the diagram of flashover. So this is an insulator. On the top there is conductor, lower part is grounded. So flashover is occurring from the conductor to the earth, but it is not through the insulation, it is over the surface of the insulation, that is in the air. So after this type of flashover, we can reuse the insulator because it is in the air, not in the insulator. This is the oil chamber. Two electrodes are there. There is spark between two electrodes. So this is spark over voltage, and after the spark is over, we can reuse the oil. So it is also self-restoring insulation. Now let us see what are the differences between dielectrics and insulators. Now this question may be asked in the interview. Dielectric materials can store electrostatic energy by means of polarization taking place in them and also offer better insulation. So this is the basic characteristic of the dielectrics. They can store the electrostatic energy. Insulating materials offer good insulation but cannot store electrical energy. That is the main difference between dielectric and insulators. Dielectrics can store the electrostatic energy, whereas the insulators cannot store the electrostatic energy. Examples of dielectric material are mica, plastic, and oxides of various materials. Examples of insulating materials are rubber, glass, and wood. Almost all dielectrics are good insulators, but all insulators are not good dielectrics. So this is the general statement. All dielectrics are insulators, but all the insulators are not dielectrics. Now let us see what are the differences between insulators and bushings. In electrical power, a bushing is a hollow electrical insulator that allows an electrical conductor to pass safely through a conducting barrier, such as the case of a transformer or circuit breaker, without making electrical contact with it. So when we are using an electrical machines, the winding is inside the body. So we have to take out the connection from the body. So we are using bushing. So here you can see the bushing. This you might have seen in the transformer. So some part of this bushing is inserted in the transformer through the body. This is the conductor. It is passing through this bushing, and here we are taking out the connection and it is connected to the line. So in the bushing, conductor passes through the body. In case of insulator, insulators are used to isolate two conductors of different voltage levels or a line conductor from neutral or earth. This is the insulator. So this is line conductor. This is pin type insulator. So conductor passes from the top and this bottom pin is grounded. So here this complete is solid. Conductor is not passing through this. It is either on the top, high voltage conductor is either on the top or at the bottom. So if high voltage conductor, as in case of pin type insulator, it is on the top and bottom pin is grounded. In case of string of the insulator and this type of insulator, this high voltage conductor is connected at the bottom, whereas top portion is grounded. So that is the difference between insulators and bushings. So in this lecture, I have explained the classification of insulations, then difference between dielectrics and insulators, and then difference between insulators and bushings. Thank you.